Here we have a logarithmic equation and we have to solve for x in this equation. Okay, in the first step, what I'm going to do is I'm going to get rid of the two denominators 2 and 3. So we can multiply both sides of the equation by the least common multiple of these two denominators so that we'll be able to get rid of the two denominators 2 and 3 on the left side. So the least common multiple of 2 and 3 is 6. So let's multiply both sides of the equation by 6. So 6 times log x to the base 10 negative 3 over 2 positive 11 negative log x to the base 10 over 3 equals to 6 times 2. Okay, now the two terms are in addition inside the square bracket. We can distribute this 6 to this one and this one. So when I do so, I'll be getting 6 times log x to the base 10 negative 3 over 2 positive 6 times 11 negative log x to the base 10 over 3. So 6 times 2 is 12 on the right side. So here 2 goes into 2 one times, 2 goes into 6 thrice, and 3 goes into 3 one times, 3 goes into 6 twice. Okay, now we have 1 in denominator here and here. It can be ignored. So now we can distribute this 3 to log x to the base 10 and negative 3. When I do so, I'll be getting 3 times log x to the base 10 negative 3 times 3 is 9. And the same thing, we have to distribute this 2 to 11 and negative log x to the base 10. Then I'll be getting 22 negative 2 times log x to the base 10 equals to 12. Okay, now, so what we can do is we can combine the two numbers over here, negative 9 and positive 22. So the simplification of this one is positive 13, and we can write the terms which contain logarithm together. So we'll be writing 3 log x to the base 10 negative 2 times log x to the base 10. So the simplification of this one is positive 13 equals to 12. Okay, to solve for x, I have to subtract 13 from both sides. When I subtract 13 from both sides, so the 13, positive 13, negative 13 will cancel, and this is simplified to negative 1. Okay, so the resulting equation is going to be 3 log x to the base 10 negative 2 log x to the base 10. On the right side, 12 negative 13 will become negative 1. Okay, here we can use a power rule of logarithm. That is, whenever there is a number multiplied in front of logarithm, it can be taken as the exponent for the argument x over here. Then I'll be getting log x cubed to the base 10. And the same thing, this 2 can be taken as the exponent for the argument x. Then I'll be getting negative log x squared to the base 10 equals to negative 1. Okay, here two logarithms are in subtraction with the same base. So we can use a quotient rule of logarithm. So whenever two logarithms are in subtraction with the same base, we can take logarithm once with the base, what we have for the two logarithms, and we have to divide the arguments. So when I divide the arguments, I'll be getting x cubed over x square equals to negative 1. So the simplification of x cubed over x square is just x. So I'm getting log to the base 10, x equals to negative 1. Okay, so now we have to solve for x further. We have to get rid of this log to the base 10. Actually, this equation is in logarithmic form. Okay, to solve for x, what I need to do is I have to convert this equation to exponential form. Okay, to convert this equation to exponential form, I have to move this logarithm along with its base to the other side of the equation. When I move this logarithm along with its base 10 to the other side of the equation, I have to ignore logarithm. I have to consider only the base of the logarithm on the other side, and the value which already exists on the other side will become the exponent of this base 10. On the left side, we just have x. Okay, now we have solved for x. The value of x is equals to 10 to the negative first part. So the correct answer choice for this question is option A.